So for our warm-up, what we have is we have this. It's really easy. 1/2 times 2. And we already said it. Everybody already said it. The answer is 1. Pretty easy, right? Now this one's going to be a little bit harder. I want you to try this one. 2/3 times something is equal to 1. So now I want you guys to figure that out. 2/3 times something is equal to 1. 2/3 times something is equal to 1. Raising our hands, who has the answer to this? Madison.
You want me to tell you the answer?
The answer.
I swear to God.
What? I apologize for the rude interruption, Madison. What is the answer?
I got 3/2.
She got 3/2. Let's see. Who agrees with her? Who agrees with her? That's because Ben got 1 1/2, which once again is the mixed number version of that. Exactly. So if we did this over here, we had 2/3 times 3/2 equals 1. There's 2 ways that we can go about doing this. 2 times 3 equals 6. 3 times 2 equals 6. 6/6 equals 1, right? That's one way we could do it. The other way we could do it is cross-canceling, and we literally just get 1. So what we found, what we were finding, so Miles asked a good question. He said, how do you multiply a number bigger than 1 to get an answer that is 1? How do you multiply a number bigger to get something smaller? What do we think, Liam?
Physically impossible.
It is not physically impossible. There is a way we can do it. Rocco? Yes, because the first number is smaller than 1. The way we can get an answer when we multiply a number bigger than 1 to get something 1 is we're multiplying the number bigger than 1 by a number smaller than 1. So they cancel each other out. 1/2 times 2. 1/2 times 2. 2 is bigger than 1. 1/2 is smaller than 1. So we get an answer that is 1. The answer isn't always 1. For example, if I decided to multiply 4 times 1/8, right? Then we're going to get 1/2, just the way that it goes about. So multiplying can result in getting numbers smaller than one of them. What essentially we're finding is like the midpoint almost. It's kind of like the midpoint. So let's look back at this, because this is an important concept that we're covering. What we've just learned, what we've just seen is called reciprocals. So reciprocals are any two numbers with a product of 0 or 1, a product of 1. This term, reciprocal, will play a huge part in any time we are dividing with fractions. In fact, we won't be able to divide with fractions without our reciprocals. There is a way to, and I'm going to teach you the separate way, and it's a fun name for it, but reciprocals are going to be the fastest, easiest, and most efficient way to divide with fractions. So I want you guys to tell me, raise your hand, tell me the reciprocal of 7/3. The reciprocal of 7/3. Elsie. Yeah, it's 3/7. That's the reciprocal. So Romario, what's the reciprocal for 3/4? What's the reciprocal? What is it, Romario? It's going to be 4/3. 4/3. What about the reciprocal of 2? What's the reciprocal of 2, Fernando? 1/2, just like in our warm-up. So the reciprocals can be fractions. Our reciprocal can be a whole number. Our reciprocal can be any sort of thing. What it is it's just that initial number flipped. And as such, I have a really cute term. So I like to call it the reciprocal, because you're just flipping the fraction upside down. So we're just flipping it to become 3/2. So I want you guys to tell me, somebody tell me, what's the relationship between the numerator and the denominator of a number and its reciprocal? So that's a lot of words that we heard. But tell me the relationship between the numerator and denominator of a number and its reciprocal. Yes, Romario?
I mean, like, really think about it, if they're numbers.
If you really think about it, they are numbers, but why are they related? What's the relationship between them? Rocco.
It's like the same numbers, it's just the denominator and numerator switch.
Yes, it's the same exact numbers, except the denominator and the numerator are switched.
they have different-
Same numbers. So for example, let's look at this. 3 divided by 1/2. 3 divided by 1/2. Do we know how to divide fractions?
Yeah.
No, we have not learned how to divide fractions yet. We have not learned it. But what did we learn so far? What have we learned? What have we learned? We have learned how to multiply fractions. So I want you guys to write this as a multiplication problem. I want you guys to write this as a multiplication problem. So, Lily, what's the equation?
I do 3 times 1/2.
3 times 1/2, right? Is that what we do? No. What can we do? Hold on, what can we do, Jenna? 3 times 2. And why is that the thing? How did we do that, Ben?
Divide fractions, so we flip the...
Correct. We can't divide fractions, so instead we multiply by the reciprocal, or we multiply by the reciprocal. To divide by a fraction, all you do is you multiply by its reciprocal. So to divide by a fraction, all we do is multiply by its reciprocal. So for example, 5 divided by 2/3 is the same as 5 times 3/2. Those are the same exact things. So this is our first method that we can learn how to do this. And I want to show you why it works. I'm going to explain to you the background of it and give you a really fun name for it. Here is my proof. We already know that when we multiply, we need to have them both be fractions. So what would the fraction... Remember when we multiply, we can't multiply by anything but fractions and stuff. How do I make 5 into a fraction? How do I make it into a fraction, Madison? 5/1. Anything over 1, right? Now, if we were dividing things, when I divide 2 divided by 3, I write that out as 2/3. Remember, this little thing is just our placeholders, right? So, this is going to look a little bit complicated, but it's actually not, and then I'm going to teach you the proof. So, here we have 5/1, and we are dividing that by 2/3. So look at that. That looks pretty intense right there, doesn't it?
Yes, very.
That looks pretty intense right there. But that's how we would write this out if we were doing division. That's how we would write this out with division. Because we have our top number, which is 5/1, and our bottom number, which is 2/3. Now, I like to call this method the Bellybutton Method. And I'm going to show you why I call it the Bellybutton Method. What we do is we multiply our outies and our innies. We multiply our outies and our innies. So in this case, what's 5 times 3? What's 5 times 3?
15.
Miles. We get 15. And in this case, what is 1 times 2? Romario? 2. So our answer would be 15/2. Let's check our work. 5 times 3/2. Once again, we get 15/2. Exactly the same answer. So I like to call this the Bellybutton Method. In this case, the Bellybutton Method. What we have is we have the numerator of the first over the denominator of the first. We're dividing this big, thick dividing line by the numerator of the second and the denominator of the second. We multiply those and we have outies over innies. So it's outies over innies. And it looks like this. We see all these complicated things. We see these N's with 1s, these D's with 2s. We see all of that. All this simply means is if I had 2/3 divided by 4/5. This one is our first fraction. This one is our second fraction. So the numerator of the first fraction is 2. The denominator is 3. We put that over 4/5. As we see, numerator of the first over denominator of the first. Numerator of the second over denominator of the second. Exactly the same as we do fractions. And when we multiply by our reciprocal, 2/3 times 5/4. That's numerator of the first times denominator of the second. We get 10/12, which becomes 5/6. But that's not the point. That's not the point. Once again, numerator of the first times denominator of the second. What this method is, simply the proof. This is the proof as to why multiplying by reciprocals works when dividing. Now, I've got a question for you. I'm going to give you two problems, and you're going to tell me which one is correct and which one is incorrect. Here's this problem. Our initial problem is 5 divided by 3/2. 5 divided by 3/2. So, when we go to solve this, which one works? Does the first one work? Does the second one work? Or do they both work? What do we think? Rafi? He thinks the second one works. Does anybody object?
Wait, what? Yes.
Trey thinks they both work. Who else thinks they both work? A couple people? Now, here's the answer. Rafi is correct. When we are doing this, we can only do the reciprocal of the fraction we are dividing by. Of the fraction we are dividing by. So the one on the right-hand side, that's the only one we can flip. We cannot flip the first one. Once again, I'm going to show this to you with our proof, with our belly button proof. So this is 5/1 divided by 3/2. We get 5/1 divided by 3/2. We do our belly button method. We get 10/3 for our answer. Outies over innies. 5 times 2 over 1 times 3. We get 10/3. Excellent. Let's check our other ones. 1/5 times 3/2 or 5/1 times 2/3. 1/5 times 3/2 gets us 3/10. 5/1 times 2/3 gets us 10/3. Which one matches our proof? The first one or the second one? The second one matches our proof. So when we're doing this, we can only do the reciprocal of the second one, of the one we're dividing by. So Lucy brought up a great fact here. She said that when you were younger, you were told don't mix up the numbers when you subtract. And yeah, that is a big deal. If we're doing addition, if we have 10 plus 7, we get 17. What about 7 plus 10? What do we get? 17. Same thing. When we subtract, if we had 10 minus 7, what do we get? 3. What if we had 7 minus 10? We get -3. Are those the same answer? No, we can't switch them up. What about with multiplying? 6 times 4. What do we get?
24.
We get 24. What about 4 times 6? What do we get? 24. Those don't matter. But what about this one? If we add 6 divided by 4, that's how we're going to get 3/2. It doesn't matter. I'm going faster. But what about 4 divided by 6? Then we're going to get 2/3. So one thing we notice is when we mess up our subtraction, we get the opposite number. When we mess up our division, we get the reciprocal number. So when we mess up our subtraction, we get the opposite number, but when we mess up our division, we get the reciprocal number. That's why you have to remember you can't mix up the order for subtraction and division. Subtraction and division we have to do in a very specific order. In your agenda, write down your homework is page 309. Miles asked a good question. He said, can you cross cancel? And I said, yes, but you can't cross cancel unless you're multiplying. You can't cross cancel unless you're multiplying. So you can't cross cancel when it's in its division form. Even if you really want to, even if you had 4/7 divided by 8/4, we cannot cross cancel. That we cannot do. It can only be in multiplication form. Yet again, homework is page 309 only.